Hello, my name is Hakim and this is my Engineering Math 3 assignment. Now, Euler's method, the definition is a numerical technique used to approximate solutions for ordinary differential equations, ODE. The formula yn plus 1 equal to yn plus h times function xn yn. Now, yn plus 1 is the next value of y. Yn is the current value of y. H is the step size, and function xn yn is the derivative at the point yn, xn yn. Now the question, for dy over dx equal to x squared plus 1 over y, where y is greater than 0, given the initial value y is equal to 1 when x is 0, find the approximate value of y when x is equal to 1. Now the step size that we're going to use is 0.2. Now the question is asking us to find the value of y when x is equal to 1. Using this formula, we know that the value of y0 is 1 and x0 is 0. Substituting that into this formula, we'll get, substituting the value of y0 into this equation, we'll get y1, which is how we got hit this. This is the example of how we use the formula. And doing that so on, if you want to find y2, we use the same formula but changing y1 to y2 and y0 to 1, and the function change to x1 and y1 to find y2. The step size remain the same. And what we did for xn here, to find, for example, x1, we use x1 minus 1 plus the step size to get x1, which is 0.2. And doing that so for, like, for example, x2, we use x2 minus 1 plus the step size, we get 0.4. And doing that so for, we get the graph here drawn. Now this is the general solution that we use, that I did to calculate, which we get 1.9485 in the end, which is close to the yn here, the value of. Now why we stop at x1 is because the question asks us to find the value of y when x is equal to 1. Here x is equal to 1, so we get 1 point. So the value of y is 1.90947. And we can conclude in the end that the larger the step size, the larger the margin of error. Like for example here,